A magnitude 6 earthquake just struck Eastern Samar in the Philippines at 2:09 p.m. local time today, less than 48 hours after Mayon Volcano produced a major paroxysmal eruption, while Mount Kanlaon shoots ash plumes 700 meters into the sky and Mount Marapi continues erupting across the Sunda Arc. PHIVOLCS is currently maintaining active alert status on 4 Philippine volcanoes simultaneously, the first time in recent monitoring history, and the agency used a word in tonight's bulletin it does not usually use. Here is what the next 72 hours will tell us, and why you need to pay attention. A magnitude 6 earthquake struck Eastern Samar in the central Philippines at 2:09 p.m. local time on Monday, May 4th, 2026. The epicenter was located 9 kilometers northwest of San Julian, Eastern Samar, at 06:09 UTC. Within minutes, residents across multiple provinces rushed out of buildings, classes and government offices were ordered shut, and authorities began a province-wide damage assessment. The shaking was felt across the entire Visayas, into the southern Bicol region, and as far south as northern Mindanao. The felt area envelope reached approximately 700 kilometers in diameter. PHIVOLCS, the Philippine Institute of Volcanology and Seismology, the agency that monitors Philippine earthquakes, reported intensity 5 shaking, classified as strong, in Canavid, in Eastern Samar, in Dulag and Alangalang in Leyte, and in Gandara in Samar. Intensity 4, classified as moderately strong, was reported in Abuyog, Palo, and Carigara in Leyte, and in Calbayog in Samar. Eastern Samar Governor Ralph Vincent Everdone ordered the suspension of classes and government office work across the province to allow authorities to conduct a full safety assessment. Police chiefs in San Julian, the town nearest the epicenter, reported minor cracks at the police station, no major damage at the municipal hall, and structural cracks at a church in town. In Oris town, residents and church officials confirmed that a heavy crucifix bearing a Christ figure fell from the altar of the San Pedro Calungsod quasi-parish in Barangay San Eduardo during the strong shaking. Reports of additional minor damage from across Eastern Samar are still being compiled and verified at the time of this briefing. PHIVOLCS confirmed there was no immediate tsunami threat. 5 aftershocks of magnitude 2 or greater were detected in the first hour after the main shock. The largest aftershock so far registered magnitude 3.2, just 4 minutes after the initial rupture. As of the time of this report, no fatalities or major injuries are confirmed, but that is not the story. The story is what was happening across this same archipelago in the 24 hours before the earthquake hit, and the open scientific question of whether what comes next is the end of the sequence or the beginning of something much larger. The earthquake struck less than 48 hours after Mayon Volcano in Albay province produced a major paroxysmal eruption on Saturday, May 2nd. Mayon ejected a fast-moving pyroclastic density current, a ground-hugging avalanche of gas, ash, and rock at hundreds of degrees Celsius, approximately 4 kilometers down its southern flank. Approximately 3,000 residents evacuated from the 6-kilometer permanent danger zone. Ash drifted across at least 52 villages in Camalig, Guinobatan, Daraga, and Legazpi City. Mayon remains at PHIVOLCS Alert Level 3. PHIVOLCS, monitoring on May 3rd, recorded 32 volcanic earthquakes, 284 rockfall events, and 14 pyroclastic density current signals in 24 hours. Lava is still effusing through 3 primary gullies on the southern flank. In the same 48-hour window, Mount Kanlaon on Negros Island produced 5 ash emissions and 49 volcanic earthquakes. Grayish ash plumes rose up to 700 meters above the summit. Kanlaon is at Alert Level 2. Across the Sunda Arc to the southwest, Mount Marapi in Indonesia continued an ongoing eruption at PVMBG Alert Level 3. Hot rock falls traveled up to 1,900 meters from the vent. Pyroclastic activity is sustained at Mount Bulusan in Sorsogon and Taal Volcano in Batangas, both at Alert Level 1, and the picture becomes unprecedented. PHIVOLCS is currently maintaining active alert status on 4 Philippine volcanoes simultaneously. This is the first time in recent monitoring history that the agency has held that many volcanoes at active alert at once. To put that in perspective, the Philippines is home to 24 active volcanoes total. Having a quarter of them under active alert, all on the same day, a magnitude 6 earthquake struck the same archipelago, is not a routine state for the country. The combination of 3 concurrent volcanic eruptions and a major earthquake inside one weekend has triggered the obvious question across the country and across Filipino social media tonight. Are these events connected, or is this independent activity inside the most active subduction system on Earth? Some viral framings circulating tonight are claiming the volcanoes triggered the earthquake. Others are claiming the earthquake triggered the volcanoes. A third framing claims both are evidence of something larger building beneath the entire Pacific Ring of Fire. The honest answer requires understanding what just happened beneath the seafloor. and that is where the agencies disagree. 3 agencies have published initial solutions for today's earthquake, and they do not agree. PHIVOLCS reported the earthquake as magnitude 6.1 at a depth of 10 kilometers. The United States Geological Survey reported it as magnitude 6.0 at a depth of 73.3 kilometers. The German Research Center for Geosciences reported magnitude 6.0 at 75 kilometers depth. The magnitude difference between agencies is small and routine. The depth difference is not. 63 kilometers separates the PHIVOLCS solution from the international solutions, and that gap is not a rounding error. This matters because a 10-kilometer deep rupture and a 73-kilometer deep rupture tell completely different stories about what just happened beneath the Philippines. A 10-kilometer rupture would place the earthquake in the upper crust, most likely on a near-trench thrust fault or a shallow splay fault inside the upper plate. A rupture geometry like that carries elevated tsunami potential because shallow rupture on a thrust fault is the classical mechanism for displacing the seafloor and generating a tsunami wave. The fact that PHIVOLCS issued no tsunami warning suggests that even under the shallow interpretation, the rupture did not displace enough seafloor to cross the threshold. A 73-kilometer rupture would place the earthquake inside the descending Philippine sea plate itself. That is an intraslab event, driven by the bending, dehydration, and metamorphism the plate undergoes as it sinks into the mantle. Intraslab events tend to produce strong shaking across wide felt envelopes, exactly the 700-kilometer envelope reported today, but they rarely produce tsunamis because the rupture surface is dipping inside the mantle rather than displacing the seafloor. Agency-reconciled solutions typically converge within hours to days as additional seismometer data is incorporated. Until that reconciliation happens, every framing of this event is preliminary. The depth determines the mechanism. The mechanism determines the aftershock distribution. The aftershock distribution determines what happens next. Whether the rupture was shallow or deep, the source is the same, the Philippine Trench subduction zone. This is the western Pacific boundary where the Philippine sea plate is being driven westward beneath the Philippine archipelago. The convergence rate is approximately 80 millimeters per year, among the fastest plate boundary motions on Earth. For comparison, that is roughly twice the rate at which the Pacific plate is sliding past California along the San Andreas Fault. The Philippine Trench has a documented history of large ruptures. The 1988 MW 7.3 event ruptured a portion of the plate interface. The 2023 MW 7.6 event ruptured a different portion of the interface. The 1897 Northern Samar Mess 7.3 is the long baseline historical anchor on this segment. What matters is what is between those events. Large segments of the Philippine Trench remain seismically quiet over the instrumental record. That means stress is accumulating across those segments without being released. The Philippine Trench is theoretically capable of producing a megathrust earthquake of magnitude 8.5 or greater. A magnitude 8 rupture on this trench would generate a damaging tsunami impacting the eastern coasts of Samar, Leyte, and northern Mindanao within minutes, with potential trans-Pacific propagation across the entire ocean basin. In absolute terms, today's magnitude 6 is small compared to that ceiling. The energy released today is roughly 2 orders of magnitude below a megathrust event. A magnitude 8 rupture would release approximately 1,000 times more energy than today's earthquake. A magnitude 9 rupture would release approximately 30,000 times more energy. Today's event sits at the lower end of the spectrum of ruptures this trench is capable of producing. The question is not whether today's earthquake itself is the catastrophe. It is not. The question is whether today's earthquake is the warning shot. That question matters because subduction zones do not load stress evenly. Stress accumulates on locked segments of the plate interface, patches where the descending plate and the overriding plate are stuck together, building elastic strain over decades or centuries. When a locked patch fails, it produces an earthquake. The size of the earthquake depends on the size of the patch that fails. Small patches produce magnitude 6 events. Larger patches produce magnitude 7 events. The largest patches, the ones that have been locked for centuries, produce the megathrust events that reshape continents and generate trans-Pacific tsunamis. The Philippine Trench has both kinds of patches along its length. Some segments are failing regularly. Other segments have been quiet for centuries. Today's event is on the regularly failing end of that spectrum. The quiet segments are the unknown. PHIVOLCS. Bulletins have a routine vocabulary. After a moderate earthquake, the agency typically issues a short statement noting the time, magnitude, depth, epicenter, and the standard phrase, aftershocks are expected. The agency rarely appends the word damage to that phrase. Today's bulletin includes both. PHIVOLCS stated explicitly that damage and aftershocks are expected. That phrasing is not routine. It signals that the agency's internal seismic source modeling is anticipating additional rupture activity of significant size in the hours to days following the main shock. The early aftershock data supports the concern. 5 aftershocks of magnitude, 2 or greater, were detected within the first hour after the main shock. The largest registered magnitude, 3.2, just 4 minutes after the initial rupture. That early hours rate is on the low end for a magnitude 6 subduction event. Comparable events typically produce 50 to 200 aftershocks above magnitude 2 in the first 24 hours. Today's rate is below that pace. A low aftershock rate in the first hour is not, by itself, alarming. It can simply mean the sequence is starting slowly, with the bulk of the aftershocks arriving over the following 12 to 24 hours, rather than in the first 60 minutes. But combined with PHIVOLCS adding damage to its bulletin language, the signal is consistent. The agency is forecasting that more is coming. The question is whether what is coming is a normal aftershock sequence, or something larger. There's a separate issue to flag: the intermediate depth interpretation, with the rupture located 73 kilometers below the seafloor inside the descending Philippine sea plate slab, can produce aftershock sequences that look different from shallow crustal events. Interslab events sometimes generate fewer but larger aftershocks, with the seismic energy concentrated in a smaller number of moderate magnitude follow-on ruptures rather than spread across hundreds of small events. If the intermediate depth interpretation is correct, the low first-hour aftershock count may be a feature of the rupture mechanism rather than a sign that the sequence is unfinished. We will know more as the depth solution converges. There is a near-perfect direct precedent for today's event, and it happened 7 years ago. On April 23, 2019, at 1:37 p.m. local time, a magnitude 6.5 earthquake struck Eastern Samar. Depth, 65 kilometers. Epicenter 9 kilometers northwest of San Julian. That is the exact same descriptor used for today's earthquake, same fault system, same coordinates, same depth range. The 2019 event injured 48 people and damaged about 245 homes. It produced 172 aftershocks ranging from magnitude 1.6 to 4.6 over the first week. The largest aftershock peaked at 4.6. The sequence decayed normally and did not escalate. The 2019 event was a singleton. Today's earthquake is geometrically a near repeat of the 2019 event, at a slightly smaller magnitude and a slightly greater depth in the exact same location. This kind of repeating source behavior on the same fault structure is documented in subduction zones. It is sometimes called characteristic earthquake behavior. The interpretation is straightforward. The fault structure that failed in 2019 has, by all available evidence, failed again today. What does that tell us about the next rupture? It tells us the structure is active. It does not tell us when the next failure will come, or how large it will be. The 2019 sequence didn't escalate. That argues mildly against today's event being a foreshock. But 2 events on the same structure, separated by 7 years, is a small sample. It establishes a pattern. It does not predict the next data point. The geometric repeat at the same coordinates is the single strongest piece of evidence in the singleton versus foreshock interpretation question, and the evidence is mixed. The 2019 precedent argues for singleton. PHIVOLCS' damages expected language argues for foreshock. Neither is conclusive. The next 72 hours will tell us which framing wins. Statistically, every earthquake is a candidate for shock until a larger event either occurs or fails to occur. The empirical foreshock rate, the probability that an event of magnitude m is followed within days by an event of greater magnitude on the same fault system, is roughly 5 to 10% globally. For subduction zones specifically, foreshock to main shock sequences are rarer than for shallow continental events. But they happen. The most cited modern example is the Tohoku precedent. On March 9, 2011, a magnitude 7.3 earthquake struck off the Sanriku coast of Japan. 2 days later, on March 11th, the magnitude 9.0 Tohoku earthquake ruptured the same plate interface. The ensuing tsunami killed approximately 20,000 people and triggered the Fukushima nuclear disaster. In retrospect, the March 9th event was identified as a foreshock, but no agency identified it as such in real time. Foreshock recognition before the main shock occurs is one of the unsolved problems in earthquake science. 3 pieces of context shape today's foreshock probability assessment. The first context is regional activity. The Western Pacific has been seismically active for months. Major events on the Tonga-Kermadec subduction system, the Indonesian Arc, and the Japan Trench have all occurred within the past several weeks. Background rates of magnitude 6 or greater events along the Pacific Ring of Fire are elevated above long-term means. This raises the prior probability for additional large ruptures across the broader system. The second context is the 2019 precedent. The previous magnitude 6.5 event at the same epicenter was a singleton. That mildly argues against today's event being a foreshock, though mildly is the operative word. The third context is the PHIVOLCS bulletin language. The agency's use of damages expected suggests internal modeling that assigns non-trivial probability to larger ruptures coming. The honest answer is that the probability today's earthquake is followed within 72 hours by a larger event on the same fault system is somewhere in the range of 5 to 10% under standard global statistics, possibly slightly elevated above that under current Western Pacific conditions. That is not a forecast. That is a description of how thin the evidence floor is for any prediction at this stage. The Tohoku precedent shows that a magnitude 7 foreshock to a magnitude 9 main shock is possible. It does not show that today's magnitude 6 is on the same trajectory. It shows the trajectory cannot be ruled out. The intuitive claim circulating across Filipino social media tonight is that 3 concurrent volcanic eruptions and a major earthquake in the same archipelago inside 48 hours cannot be coincidence. The mathematics disagree. The Philippines records approximately 6 earthquakes of magnitude, 6 or greater per year on average. The country has 6 volcanoes at active alert status at any given time. A 48-hour window where 1 magnitude 6 earthquake and 1 major eruption coincide is statistically expected to occur several times per year on the Pacific Ring of Fire. That is the easy answer. The harder answer is the physics. Coulomb stress changes from a magnitude 6 earthquake typically peak at a few tenths of a bar within 50 to 100 kilometers of the rupture and fall off rapidly with distance. Mayon is approximately 250 kilometers from today's epicenter. Kanlaon is approximately 295 kilometers away. The static stress change at those distances is at or below 0.01 bar. That is, orders of magnitude below the threshold typically associated with documented earthquake-triggered magma ascent. There is one well-documented historical case where Philippine earthquake-volcano triggering has been seriously argued in the scientific literature. On July 16, 1990, a magnitude 7.8 earthquake struck Luzon, approximately 100 kilometers northeast of Mount Pinatubo. 11 months later, on June 15, 1991, Pinatubo erupted in a VEI 6 event. That was the second largest volcanic eruption of the 20th century, ejecting approximately 5 cubic kilometers of material and cooling the global climate by half a degree Celsius for 2 years. Researchers including Bautista, Stein, and Punongbayan published analyses suggesting the 1990 earthquake produced a compressive stress change of approximately 1 bar on the Pinatubo magma reservoir. That stress change was potentially enough to nudge the system toward eruption. The proposed mechanism was either direct compression of the reservoir squeezing magma toward the surface or strong shaking dislodgement of the upper plumbing system. The USGS itself characterizes this connection as speculation that is, quote, impossible to prove conclusively. Here's the critical comparison. The 1990 Luzon earthquake was magnitude 7.8. Today's earthquake is magnitude 6, that is 2 full magnitude units smaller. Today's event released approximately 250 times less energy than the 1990 case. It is too small, by a wide margin, to be considered a probable trigger for Mayon's ongoing eruption. The reverse claim, that Mayon's eruption triggered the earthquake, is also unsupported. Magma ascent inside the volcanic edifice cannot transfer meaningful stress onto a slab fault, 73 kilometers below the seafloor, 250 kilometers away. The defensible scientific position is that today's earthquake and the ongoing Mayon eruption are independent expressions of the same underlying subduction system. They are not causally connected to each other. They are co-produced by the same engine, the Philippine sea plate descending beneath the archipelago at 80 millimeters per year. The 4 volcano simultaneous alert status and the earthquake are the same phenomenon expressed in 2 different ways. A Pacific Ring of Fire that is unusually active but not coordinated. 2 pieces of imagery have dominated Filipino social media tonight, and both deserve a clear answer. The first is video and photographs of a heavy crucifix bearing a Christ figure falling from the altar of the San Pedro Calungsod quasi-parish in Barangay San Eduardo, Oris Town, Eastern Samar. The chaplaincy is named for Pedro Calungsod, a 17th century Filipino lay catechist canonized by Pope Benedict XVI in 2012. He is one of only 2 Filipino saints. The fall of an ecclesiastical crucifix in a region named for a national saint during an earthquake that arrived 24 hours after a major volcanic eruption, has become the defining cultural image of the event for Filipino audiences. The fall itself is structural mechanics, not a metaphysical sign. Heavy ecclesiastical objects mounted at altar height in older Filipino chapels are typically attached using methods that perform poorly under horizontal acceleration. PHIVOLCS. Intensity. 5 shaking is more than sufficient to dislodge them. This has happened during Philippine earthquakes for centuries. The cultural and emotional weight of the image is real and worth honoring. The physical event is not anomalous. The second piece of imagery is video of farm animals, dogs primarily, reacting in apparent panic seconds before the surface shaking arrived. This is consistent with detection of the P wave by sensitive hearing. The P wave is the primary seismic wave. It travels faster than the S wave that produces most of the destructive shaking, and it arrives at the surface a few seconds earlier. Dogs hear in a frequency range above human hearing and detect ground vibrations more sensitively than humans do. The reported loud bang some witnesses describe before the shaking starts is consistent with the P wave arrival itself. This is not paranormal precognition. This is dogs detecting a real signal a few seconds earlier than humans do. Earlier scientific work on animal earthquake precursors, including a 2019 study on oarfish strandings versus Japanese earthquake catalogs, has not found evidence that animals provide reliably actionable seismic precursors at meaningful lead times. The cross and the animals are both real signals, but the signal they carry is the earthquake itself, not anything beyond it. 3 scenarios are live for what happens next. The first scenario is routine Pacific Ring of Fire activity. Today's event is a typical intraslab rupture inside the Philippine sea plate, geometrically nearly identical to the 2019 event at the same location. The Mayon eruption is independent ongoing activity. The aftershock sequence will follow Omori decay over weeks. The largest aftershock comes in approximately 1 magnitude unit below the main shock, between magnitude 4.6 and 5.1 under Bath's law. Life resumes. This is the modal expectation under standard subduction zone seismology, and the probability assigned to this scenario is the highest of the 3. The second scenario is stress concentration along the Philippine Trench. The 2023 magnitude 7.6 event, the 1988 magnitude 7.3 event, and the 2019 magnitude 6.5 event represent partial ruptures of segments of a long Philippine Trench megathrust system. Today's earthquake reactivates the same segment that failed in 2019. Under this interpretation, the trench is in a phase of stress accumulation with periodic magnitude 6 to 7.6 partial ruptures across its length. A future magnitude 8 or greater rupture remains an open possibility on a multi-decade to century timescale. Today's event is a marker on that long arc, not a foreshock to a near-term main shock. The third scenario is the foreshock case. Today's magnitude 6 is the leading edge of a sequence that produces a larger event within days to weeks. The 2011 Tohoku precedent shows that subduction zone foreshock main shock progressions do happen. The PHIVOLCS, damage is expected language, and the elevated Western Pacific activity backdrop both raise the prior probability slightly. Under this interpretation, the next 72 hours are critical, and additional ruptures of magnitude 6.5 to 8.0 are non-trivially likely on the same slab structure or on the adjacent megathrust interface. The framework here is to refuse to commit to any one of these prematurely. The honest scientific answer is that no current method allows a confident foreshock determination within the first hours of an earthquake. The probability of the third scenario is somewhere in the range of 5 to 10%. That is not a forecast. There are 5 concrete things to track over the next 72 hours. First, watch the magnitude depth solution. PHIVOLCS will publish updated bulletins as the agency reconciles its solution with the international agencies. Watch for whether the depth converges toward 10 kilometers, indicating a shallow tectonic event, or toward 73 kilometers, indicating an intraslab event. The 2 interpretations imply different aftershock distributions and different stress transfer footprints onto neighboring volcanoes. Second, watch the aftershock count. A normal magnitude 6 subduction sequence will produce 50 to 200 events of magnitude 2 or greater in the first 24 hours. The current rate is below that pace. If the rate stays low, that is consistent with the singleton scenario. If it accelerates, that shifts the assessment. Third, watch for any aftershock that exceeds magnitude 5. Bath's law expects the largest aftershock to register between 4.6 and 5.1. An aftershock above 5.5 would be outside the expected envelope and would shift the foreshock probability assessment upward. Fourth, watch Mayon. The volcano remains at PHIVOLCS alert level 3 with active pyroclastic density currents and ongoing lava effusion. Any escalation to alert level 4 would be a separate developing story driven by Mayon's own internal magma dynamics, not connected to today's earthquake, but it would mean the Philippines is dealing with two simultaneously escalating crises. Fifth, watch the Philippine Trench more broadly. Any additional magnitude 6 or greater event on the trench within the next week, anywhere along its length, would shift the regional stress assessment significantly. The trench is one continuous structure, and stress released in one segment redistributes onto adjacent segments. The most likely places to look are the segments that have not ruptured in the instrumental record. The Philippine sea plate will keep driving westward at 80 millimeters per year. The slab will keep descending. The next rupture, small or large, days from now or decades, is already in the process of happening somewhere in the rock beneath the Visayas. We just do not yet know how big it will be. We'll be tracking this as it develops. That is the briefing.